Join discord.gg/flatearth and enter a check-in room. Someone will come along and verify you to get involved in the conversation about our Earth.
Oh, but I think he is. I think he's finally going to break the spell and bring forth, globe proof. So go ahead, .pb. Tell him how you know the Earth is a globe. Don't let me down now.
Trust me, I didn't join the server to prove it. I'm just
Well, I'm telling these guys that you're going to tell them how the evidence for the Earth is a globe, bro, and you're letting me down, bro. Come on, let's give him the old thunder punch.
Nah, man. I'm here to the Antarctica stuff and all.
Oh fuck,
I'm more into
Antarctica.
that.
What about it? What?
I don't know. They never published the stuff about the expedition, so I was super skeptical. So yeah, I joined
skeptical.
here.
Super skeptical too. That's awesome.
Hey,
yeah, I'm mostly here for the resources. Trust me.
Oh, you want me to trust you? Okay, I'll trust you.
We're the resources.
I didn't know that's what you wanted me to do. Now that you said so, I can do so.
Yeah, I joined the channels and I can see a guy also DM'd me. And how I guess I saw the folders.
Right. Hey, but listen, you do think that the Earth is a globe, right? I didn't get that wrong.
Yeah, see, I graduated school last year, so yeah, of course.
Okay.
But I'm not here to. I'm not here to argue about that.
Argue? Who wants to argue? We want some evidence, man. We fuck arguing. We don't care about that.
Hold on. 2 seconds, Mayhem. There's no debate here, my friend. We're not here to argue.
Yeah, exactly.
Basically, what usually happens is hold on. I hadn't finished my sentence, bruv.
Yep.
So basically, we're not here to argue. We're here to present evidence. It's people that believe that they're on a ball that start arguing against a brick wall, like natural silence and laws of nature. They don't argue with us. They argue with laws of nature. There is no debate regarding the Earth being flat. It's required to be to navigate across it.
Truly, yep. See, I joined this server not to prove any evidence, not to prove the side. I'm just here for the resources. That's it.
Okay. Well, let me give you one of those resources. One of those resources is a triangle. Do you know what a triangle is?
Yeah, sure.
Awesome. So we use this for celestial navigation, navigating by the stars. Have you ever heard of that before?
Yeah, actually, the distance calculated. Yeah, I read about that.
Yeah. So you understand with celestial navigation, what we do is we read elevation angles up to stars. So that star, we call it Polaris, is 45 degrees above the horizon. That's how we use celestial navigation, correct?
Okay, yeah. Maybe I'm not sure.
Basically, let's put it like this. If you understand what a triangle is, 3 straight lines meeting at 3 vertices where you can read 3 angles reaching 180 degrees on the interior of the triangle, and you understand that we use triangulation to navigate across the stars. And if you understand that if the Earth was a curved surface, that would bastardize your triangle, make one of your lines curved where you could no longer read 2 angles. So if you want the resources, I suggest you look into celestial navigation, navigating by the stars, which demonstrates the Earth has to be flat to get around.
Okay. Yeah, Celestial. Yeah, I found the channel. Yep.
Awesome stuff. So if you're just here for the resources, there's one.
Oh, that's the horizon. Yeah. I guess in Euclidean geometry, triangles only work. In non-Euclidean, I guess triangles don't work. There was this.
See, the thing is with.
Sure.
No, go on. You finish your point. My friend. I interrupted you.
The thing was, I'm not good into maths. I'm more of a bio person. I'm in med school. So the thing is, in non-Euclidean geometry, you can have 360 degrees in a triangle.
That's awesome, but we don't use non-Euclidean geometry when we're triangulating angles to scars.
Yeah, we don't.
We use Euclidean geometry, which is 3 straight lines, 3 angles. Yes, we do.
Yep.
What was the
So,
strongest evidence you have for? Oh, sorry. Were you done, Jedi? Or were you still going on?
yeah, no, I'm done, man. You're right.
All right. So what was the strongest evidence that you have for the Earth being a globe? The .pb.
Like I'm not sure. Trust me, I'm not here to. I
You
try to
don't
be
really
free
know.
thinker.
Yeah, that's cool, but you don't know anything about the globe. Then that's fair to say. You just left high
No,
school.
I was like surely never bothered about it. Like I'm now in free time, so I was like, yeah, let's explore stuff.
Yeah, but you never bothered about it, meaning you never really retained any of the information. It's just like you learned what it was about and
Yeah,
you just forgot about it.
trust
You
me.
don't
Like physics was my least fave subject in school. So yeah, no, like
physics.
I was never.
No. Okay, so the study of the physical and natural world per the idea that you live on a globe, there's planets. You know that
Yeah,
story. Were you told that story in school?
of course. Like I last year we were taught about gravitation and the stuff what they say
Right.
rotational circulation. So tangential
Okay.
acceleration, all the stuff.
So, yeah, do you think that makes any sense to your mind, or you think that's stuff you just don't really care about? You don't care either way what they say.
Yeah, I
It
trust me.
doesn't make any sense. Like,
Yeah, I
what is,
never care about stuff. Like I don't care simply because
okay,
it's too complex for me.
complex.
Yeah,
So
like
how is
the
it?
stuff.
What way? What way is it complex? I mean, if you can
Like the
help me out
stuff
here.
they okay, like the stuff they taught, it was
Mhm.
like the tangential and centrifugal acceleration. Like how can a body in a sphere have two accelerations? I was like too confused about that. Like it's going on a straight path, but also it's bending, so it has an inward acceleration. So it circles around any like heavy mass object.
Okay, so you're telling me that all the speeds and movements of the globe are very confusing and way too
Yeah,
complicated for you to actually get
yeah.
to an understanding of you actually. So do you then? I'm just trying to get down to. So if since it's too complicated for you, you think you just believe that it's true? Would you think
Yeah, I
that's the
believe
position
that
you're taking?
to pass school. Exactly, to pass school. I had to believe. I had to get good grades to get into med school.
Okay, so you had to get good grades, but believing something to be true and maybe questioning it could be something two different things, right? You can question it and say, "Well, I'm not
Like,
really sure
it
of this
sounds like
information."
it sounds like okay. Well, let me ask you: are you a globe skeptic then? Seeing is that the theoretical physics that they proposed seems contradictory to what you know about acceleration and the fact that we don't feel anything.
Like I haven't like dug deep in this topic, but yeah, like the
Not dug deep. It's just based on what you said. I didn't say anything other than what you said. We know that angular rotation, just by itself, the rotating body, means that there's an acceleration, which would mean we could detect it. But then you also mentioned that the Earth is orbiting. Uh, it's going around other massive bodies, right? Namely the
yeah,
sun. And the sun
yeah,
is going around the galaxy. There are all of these accelerations. And how could that make sense, right? So that would make you a skeptic then, right?
yep. I exactly am a skeptic now. Exactly.
Okay. That's kind of what I wanted to know as well. So Eli kind of was going down the path of logic that I wanted you to actually talk about, which is now
Like
now that
yeah,
he elucidated that fact. Now we understand that you will become skeptical of the information, which probably hence why you're here, right? In this call.
yep, exactly.
Okay. All right.
Like
Yeah, that's good. No,
see, like in school system, like I am from a very competitive country, so in school system we can't question. We have to believe because we have
yes.
major tests and all. So
Yeah, no,
yeah,
I don't disagree with that because I know in certain countries schooling is a bit different than like the how it's done and whatnot. But yeah, I get what you're saying. But like you're now probably at an age and maybe a place in your life where you can be a bit more free in your skepticism, right? You can
yeah.
question certain things. You don't have to just accept everything. So
No,
all right,
no.
so well, I mean, if that's the case, then I think you should really take a look at the three fundamental questions that I usually ask people when they come in here, right? Now, and you being in the place that you're at, you can ask other people the same thing. And this is a non-confrontational way to actually really understand if the things that they're telling you are actually true or not, right? You're just gonna, you're not gonna, it's not a debate. You're not gonna force somebody into it. You just ask them questions. Hey, look, just tell me what you know about these topics. So the first one would be direct measurement of the Earth's curvature with drop over distance. Okay, so if we're talking about an oblate spheroid, well, they're telling you that you live on a geometric shape, right? Like an oblate spheroid, a sphere.
Yep.
So for all intents and purposes, this thing that you're standing on has a radius, a diameter, and a circumference.
Yeah.
You know that much, right?
Yeah.
Okay. So if that's true, then any point that's 2 points on the sphere, between point A and point B on a sphere, you'd have a drop over distance, or point A and point B, there would be a distance between them that would form an arc between them, right? There'd be an arc. So in that arc, there'd be a drop, and it'd be measured as such. So you could take a small sample set on that sphere and be able to detect whether or not that curvature exists or not with a small sample set, because you're using drop over distance, right? So per the metrics, right? We have the metrics of the globe. You can, if you wanted to, you can search that out for yourself. Type in what is the radius of Earth, what is the diameter, and what is the circumference. You'd be able to pull that up in Google.
64,000 kilometers. We read it in school.
That's the information. So obviously, there's some metrics to the the radius, diameter, circumference. So you already know these values exist. Therefore, the Earth that you're standing on is of a certain size. It's not big or small. It's just exactly the size that they told you that it is. And so these values are most important. So being that as it is like a standard for the Earth being that way, you can then directly measure the curvature if it's there over a small sample set. Like I said, drop over distance. It should be something easy. So when you ask somebody the question, I'm going to go back to the question, right? When you ask somebody the question, how has the Earth been measured any time in history with drop over distance? So you're asking them who has done this, right? I don't care who they say. What we're looking for here in the example is who has measured this drop over distance on this oblate spheroid that you're standing on. So that's the question you need to ask, right? When you ask that, see what kind of response you get from the people that are thinking that the Earth is a globe. And so you say, look, I don't want to argue. I just want to know what you know, and that's it. If you don't know, then you don't know. If you do know, then tell me who, and then we'll figure out if that person actually did the drop over distance measurement, which is indeed the thing that would give you the measured amount of the globe, right? At least from the small sample set. So just ask that question and see what you get. There's 3 questions, right? So that's the first one. Who has measured the curvature of the Earth directly with drop over distance? So,
like there aren't even mentions in the books like who calculated the radius and all. It's just the value. That's it.
Yeah, of course. And so this is kind of getting into the person's mind to like figure this out. So what we're attempting to do, the .pb, is we're trying to get the person to critically think about this information and challenge them. Like, because obviously everybody just takes it for granted, the information, and says, yeah, okay, the Earth is this size, without even knowing how the size was ascertained. Like, they don't know how they derived it. So that's important, right? You want to know how the person knows that the Earth is a globe by way of understanding how it was done, like the method. Does that make sense?
Yeah.
All right, so that's the first. That's the first question. But so just keep that in mind, right? How was the Earth measured with drop over distance, curvature? So the second one is going to be, the axial rotation. So, this Earth spinning on its axis. Well, they tell us that the Earth is spinning on its axis at about 1,000 miles per hour at the equator. So at the equator, the Earth is spinning at 1,000 miles per hour. Now, who has directly measured the axial rotation of the Earth? Anytime in history. Same kind of like same as the first question, right? So you're going to figure out how they know that the Earth is spinning on its axis, because that's a pretty important thing, right? Because that's what they tell us that the Earth is doing, that it's spinning on its axis. So who's done this? Like, who's measured that? And so that question is the second question. And then, of course, you're going to figure out how they figured that out. And the same as the first, you have to find out what their baseline knowledge is for that and how they got the information. and so on. So just letting you know that much. So the last one is going to be maybe something that you can get into with somebody about a. Okay, so it's the vacuum of space, right? As been told to us, and then we have the pressure air that we breathe here on Earth. So on the surface, right? You and I are breathing about 14 psi, pounds per square inch, the pressure that of air in and out of our lungs. So, but they tell us that when you go above the exosphere, right, the layer cake of all the the atmosphere and the thermosphere and all that, you get to the very top, the exosphere. Right beyond that is a Kármán line, which then transitions over into low Earth orbit, right? So then at that layer is going to be like when you start into space and you get like negative pressures of like 10 to negative 6 torr and all these kind of things. And they tell you that it's super low differential from the surface of Earth. Well, if that is the case, right, that you have this low pressure system right above the high pressure system on the surface, well, that usually has to deal with like entropy in the form of like the gas laws. And with entropy having the gas laws, if you have a high pressure system next to a low pressure system like that, with the super vast differential, then what happens is that the gas on Earth would disperse off into lower pressure and it would equalize, right? Until all the gas is dispersed and there would be no more gas and everything would be equalized with the system, which means that all the air would disperse everywhere. All into the void, just disperse. Because every time that we have gas pressure here on Earth, it's inside of a container. Every time. So every time you think about gas pressure, it needs a container. That's a necessary antecedent for gas pressure, is a container. You and I should know this, right? As far as like understanding gas pressure. You need a container if you want to have gas pressure. So the question,
they explain, explain the stuff in our chemistry classes that to stop the basic laws of gas diffusion, you need a adiabatic system where there is a layer, no heat transfer and all. But the Earth and the space isn't a adiabatic like system.
Yeah, but we're gonna figure out that if the gas laws never change, right? If we understand them to be always the same, then if you have a high and a low pressure next to each other, there needs to be a container that divides them. If there isn't a container, then the issue is the gas disperses into the lower pressure system until it equalizes with the surrounding pressure. So we understand this, right? Like on that point. So the question then would be, how is it possible to have gas pressure without a container? And in the case of the globe, that's the question. How is it possible to have gas pressure without a container? Do you see that with the question that I'm asking?
Yep. That's a legit question, actually.
Well, it's important because we're talking about the Earth being an open system. So with the Earth being a globe, matter and energy can transfer out of the system. Yeah. So you got rockets can leave the Earth, and so matter can leave, energy can transfer as well in between the Earth, and the sun can give its energy. So we have that understanding. Matter and energy can transfer. So what is gas? Gas should, in an open system, expand out into all available space until it has its equilibrium.
They teach us that in open system equilibrium, entropy, like the gas doesn't need external stimuli to expand, and it expands indefinitely. So it's an open system.
Yes. But that is the provocative question, is that how is it possible to have an open system when we have gas pressure here on Earth? You understand? So that's interesting. So we can play an audio clip, which is like the one somebody put in the live stream right now, and I want you to listen.
Okay, I saw the bit. This one, right? The entropy one?
Yeah, but for the listening audience, I want to do it also. It's only like a minute, I think. So we can... just give me a second. I'm going to load it up in the bot.
One of these bulbs, some bromine, and in the other, I have a vacuum. And if I open the tap between these two, you will see spontaneously the bromine rush from one to the other. Now that is the simplest change we can have, perhaps, because all that happens is a change in entropy. In this case, the expansion into a vacuum, nothing else is involved. There's no energy change, there's no temperature change, there's no change except entropy. So without the entropy constant.
Yeah, it's Professor George Porter, actually, on that one.
So, like, was he like a renowned scientist and all? I guess.
Yeah, you could look him up. He's that's pretty old though, like what in his 60s, 70s, something like this.
It's 60s. The clip looks like from the 70s. Yeah.
But this is well established. These gas laws are laws for a reason, right? So we understand this.
Yeah, these are like basic. They taught us as universal gas laws, so they should be applicable like in every system.
Right.
Also, like when they mainly did it for ideal gases. When they fixed it for non-ideal gases, which are like most gases, they added some terms, but they didn't change the basics. It was always the same. It's mostly they added the terms for, particle-particle collision, that kinetic energy loss. But other than that, it's basically the same.
Yeah. So understanding that law means that the vacuum of space isn't real then.
Yeah, it's truly.
Yeah. Because we understand that we're breathing gas pressure. The necessary thing that you need to have gas pressure is something to press upon. If you don't have something to press upon, you will not achieve gas pressure, and the gas will disperse infinitely until it reaches something that it can press on.
Yeah, like basic dissipation law.
Yeah. So every single story that they tell us about satellites, rockets to the moon, remote control cars on Mars, slingshots around stars with satellites for asteroid fields so they can come out the other end and take photographs of Jupiter and Saturn for you. Oh, and Jupiter and Saturn being giant balls of gas uncontained in a vacuum. That's all bullshit then, according to not me or Mayhem, just laws of nature.
The gas ball of Jupiter is like, see, the thing was you need a mass, like according to them, you need a mass to concentrate, but we have read that Jupiter doesn't have land masses or, solid mass. So how it accumulate in such a huge ball? That's the point.
Yeah. So,
gases in the vacuum.
Understanding that very simple means so the vacuum of nature and all of that, the vacuum of space and all of that stories within it are therefore debunked. They can't happen. That place called the vacuum of space cannot be real. We can start calling it Narnia.
Like it's very much skeptical because people don't question about stuff like these.
So you are from India, the .pb?
Yeah, like how the fuck do you know?
Yeah, it's like a no duh with your accent, but I don't know.
Your accent. Yeah. Makes sense.
But I'm not like mind reading checking out your IP address or some shit, man. Like I just hear your accent, so that's what I'm.
Yeah, it gives it away. True.
Well, anyway, it's difficult for you to have that kind of skepticism over there, from what I learned.
Like, of course, see, like, how do I say? There, like, I gave this med school exam. It had physics. It's like 2 million students, and they're like 100K seats. So you have to just learn stuff. That's it. Well,
I'd say this, man. Like, that's learning things and regurgitating the information just so you could pass the test doesn't qualify you of your what your intelligence is, because we've had PhDs come in here and they don't know shit. So that's not a mark of intelligence. That just means your memorization skills are really good.
Yeah, like that's entirely the basic point these days in like our education system. You just memorize stuff, you go to higher classes. That's it. That's all you need to be in like those places and even learning things. But
using your critical thinking skills, very little, if any, very little.
I remember my friend once asked in class, like, why the shape of the atom is round and why not other shapes? Basic question. The teacher said, you are here to be a doctor, not a scientist. So shut
Whoa.
up. That's it.
Yeah, that's a way to answer
so
someone.
Basically, that was don't ask questions. Just repeat what I fucking tell you.
Yeah.
And then the
That's what it
exam
is.
regurgitate it. Brilliant. So you understand, our Indian friends, that it's very easy. It's very easy to brainwash people because even within the school system, it's just regurgitation, and you can't ask questions.
Interesting. But we don't wonder why the world is the way that it is, Jedi. I mean,
well, yeah,
people
exactly.
are told not to think.
We do wonder. But it's good when people like our Indian friend, the .pb, do come in and start asking questions because they are indeed skeptical. And it's also fantastic when they listen to our responses and the information that we give and are quite nice about it. So thanks, buddy. Really appreciate it.
Okay. Like, it's like being happy to have a civil discussion, like in these topics.
Do you know much about science, my friend?
I've learned science for like my entire life. I'm getting into med school now, so yeah, I guess I know a bit.
Nice.
Awesome stuff. You mentioned gravity earlier.
Yeah.
Would there happen to be a scientific experiment that proves gravity?
Okay, see, like, I'm not proving a point. I'm just saying what we were taught. See, basically,
this is why I'm.
Hello.
Go on, carry on.
Yeah, that's fine. That's fine that you're not proving a point and you're just telling us what you were taught. But can you tell us of any experiment for gravity that you were taught about?
Yep. The new concept was, I guess Einstein gave it as space is a mesh, and the sun and the earth are like masses. So you put a mass. I probably have seen that fit on YT, I guess. Like, it's a huge rubber band trampoline type. They put a huge ball in between that. Then they throw marble.
Yeah.
It's not an experiment for gravity.
Yeah.
Go ahead, Jedi.
The reason why I asked this question. No, it's the reason why I asked this question, my friend, is you sound like an intelligent young gentleman who's been through the education system and may understand what science is. So if I was to tell you that science is experiment-based, where you must demonstrate the cause of an effect in the physical and natural world, would you then understand that there has been no scientific experiment to prove gravity, if you understand what science is?
I mean, yeah, like basically what they say in science is everything is a theorem. Like, nothing's a fact. Because they're, always trying to improvise or whatever they do.
See, this is the thing about science and how we demonstrate things to be true or not true. In a scientific experiment, when we find something happening, we want to prove the cause of that. Let's call that something happening boiling water. We understand that if I presume the cause to be heat, and in an experiment I heat up the cause for the bubbling water, correct? Awesome. So we do know things. So when you turn around to us and understand why, because scientists say that we don't know things, we do. That's what science is for. It elucidates cause of an effect. In a hypothesis, you've got two basic hypotheses. It either will cause the effect or it won't cause the effect. Demonstrating that somehow along the line you're going to prove something. It either does or doesn't. So in science, we most definitely do know things.
Like there are stuff, they just teach us that, yeah, these are facts. We know this stuff. That's why you don't have to ask, for the proofs and all.
Yeah.
And, yeah.
I'm going to ask you this question, and hopefully you follow. And if you don't, then I'll explain why. Would you be able to give me a scientific experiment that proves the shape of an object, the Earth?
No, I'm not sure. Like, I haven't read much stuff about that. I guess.
Okay. Well, go on.
Yeah, like I guess I'm only talking about school. Okay, like I'm basically talking about what we're taught, not my thoughts, the school thoughts.
Mm-hmm.
So the thing is, there are laws and all. Mm-hmm. So I guess it was the first, not the second law. So basically, it's they basically explain how rockets work and stuff, and like what's perigee and apogee.
My friend, sorry, maybe you didn't follow my question, so I'll ask you again. It's not a problem. I understand English isn't your first language. That's fine. So my question was, is there a scientific experiment that can prove the shape of an object, the Earth?
No, probably not. Like, I haven't read that stuff.
Probably. Right, so let me restate the question and tell you why it's a really bad question to ask, and I really hoped you would have picked up on it. Science isn't the tool we would use to figure out the shape of an object. Science, as I've already told you, demonstrates cause and effect relationships. Being as the Earth is said to be a shape, that's not something happening, that's a concrete noun. So basically, when I asked you, is there a scientific experiment that proves the Earth, you should have turned around to me and said, no, science isn't the tool that we would use to do that. If we want to figure out the shape of an object, we look at it and measure it, don't we?
Yeah.
Awesome. So when they turn around to us and say, science proves the shape of the Earth, you, now being a more intelligent man, can turn around to them and say, well, that's bullshit then, because science is not the tool we use to figure out the shape of things. Do you understand how easy the brainwashing is, mate?
Like, that's true, actually. Yeah.
I know. That's what I said. Usually people come in here and they don't argue with us because there's no debate. They argue against laws of nature and other things like that. There isn't a debate, my friend. But when we point out some things like what science is, and you being an intelligent man, you caught the point that I was putting down for you and you picked it up really well. So I'm very happy about that. Yeah, science doesn't prove the shape of objects.
Yeah, science basically was to, explain the cause and effect and what's happening, not proving concrete stuff and all. Like, basically science deals with stuff these days, but like there wasn't any, you say how can I explain? There's no need in science from the basic startings that to prove stuff, because that wasn't even what science once was meant to, but it's used nowadays to overshadow concrete stuff.
Would you agree that anything that doesn't follow the scientific method can be declared as pseudoscience?
No, see, I believe in spirituality, so yeah, no, I won't say that.
Okay, so I'll ask the question again. Would you say that things declared to be science that do not follow the scientific method would be pseudoscience?
That's a tough question, actually.
Is it?
Yeah.
If it doesn't follow a method, then it is not that method.
Basically, yeah, that's not science, because wasn't the point of science to the biggest argument science has against religion is, in religion people believe there is a cause, there is an ultimate factor, then they pave the way towards it. And the science people have the argument that we pave the way to a fact which we don't even know what the fact is. So if the paving doesn't explain the fact, then how is it science?
There you go. So here's another question for you. Would you agree that, I don't know, astronomy, for example, is pseudoscience? because you can't have a physical experiment. You stand on the floor, you point up at a star, and you make a declaration about it. Would you agree that astronomy is not science?
See, like where I come from, like in our ancient culture, there were stuff about astronomy and all that stuff, but scientists like these days consider that as pseudoscience. So, but
Yeah.
I truly believe in my culture.
No, that's fine for you to believe in your culture. I'm just trying to demonstrate again that people who declare things to be science that don't have an experiment are doing pseudoscience. So every time that you get somebody, I don't know, Neil deGrasse Tyson, for example, he's not a scientist. He couldn't be because man's never done an experiment based on astronomy.
True.
Awesome stuff. So even though Flat Earth does sound ridiculous, would you say that within the last 20 minutes to half an hour speaking with us that you found it less ridiculous?
See, like I never found flat Earth or the topic ridiculous, cause like see, like our lives are basically nihilism, so we need to have a purpose, right? So why not be skeptic?
Have you got any other questions, my friend?
It's like 3 a.m. So yeah, I guess I'm done. I guess like it was a great time talking to you guys. I will surely come back.
Yeah, well, we definitely, we're open 24 hours a day, my friend, so we'd love to have you back anytime. I wish you a good evening and thank you for popping by.
Tags! What is your profession? See, old friend, I brought more soldiers than you did.